So, Vanakkam. So, we are been seeing the recapping of all our basic understanding of the earthquake. So, last class we have seen the different type of earthquake sources, particularly fault and fault type, and also we have seen the different type of earthquakes. So, and depends upon the depth, location where it occurs, and what type of energy it released. Okay, so basically the tectonic earthquakes are the major concern for the human being. So, where we need to really understand. So, we also seen that this earthquake actually causes a or occur at where the fault is basically a weak zone or fracture place. Okay. So, when the earthquakes are occurring, basically what happens, the weak zone fracture and breaks. So, during that breaks actually there is a jerk and irregular progress of rupturing these two places. Even the same rock, it breaks and rupture. That rupturing basically create a seismic waves. Okay, that create a seismic wave in the form of vibration. Okay, the vibration basically is a seismic waves. Okay, so this vibration, so once it originate, it try to propagate all other direction uniformly. Okay, so all other direction uniformly, where it occurs starting point actually is called as a focus, then it try to propagate around that focus point. But as we have seen that this is occurring in the rock, so there may be a different type of rock in the places. Okay. So, that means the propagation of these waves, okay, vibrations or waves, it depends upon the material in the region. If the material is weak, okay, the rupture will propagate very fast. The material is strong, it may not propagate, it will stop. So, we also seen the asperities, barriers, okay, during this discussion in the original class, but now I am not talking about in detail that. So, the barriers is basically the stronger portion of the rock which is stop a propagation of the wave. So, the asperities is it's the propagation patches whatever happening is asperities. You can refer the old notes for the same basically or old class discussion. So, apart from the material of the rock, the another factor which controls or stops this propagation is actually the overburden pressure at that particular location. As we have seen that the earth surface is valley, ridge, all those things. So, the each location, okay, the what is the pressure we are expecting is a function of unit weight and the thickness of the material at that. This is called as a overburden pressure. This will change. I am talking into very simple term, but civil engineers may understand this in detail if those who have studied BTech in civil and all. So, this overburden pressure will change differently at a different place. This also contributes to the stopping of this wave propagation. So, basically if the overburden pressure is high, it will stop the rupture phenomena. It is a low, it will allow to propagate. So, depends the rock properties and overburden pressure, okay, will be decide what is the your. So, the rupture direction, how the rupture area, all those things will be decided by these two major factors. So, when these waves are traveling, okay, when the vibrations are traveling in the form of waves, okay, so the wave propagation, okay, occurs. Okay, so, the wave propagation occurs in the 3-4 major category way. So, what is that? Reflection, refraction, and then the dispersion and attenuation. So, what is the reflection? Reflection, as we have seen maybe in the school physics, like reflection of the light wave. Here also same, instead of light you get a seismic wave. So, the seismic wave travels from one medium because it travels on the rock when it originates. So, one property of the rock, when there is a change in the another property of the rock, like type 1 rock and type 2 rock. So, then the part of the wave get reflected, part of the wave get refracted. So, this is the reflected wave and refracted wave. This kind of phenomena is called as a reflection of the wave. So, for example, the wave, the seismic wave, okay, so created by the earthquake travels down the earth. As you see in that the earth has a crust, mantle, and the inner core, outer core. So, when it crust to the mantle, when it goes, because of the change in the property of the rock, the portion of the wave reflected, portion of the wave refracted. Okay, that is what is the refraction does. So, similarly refraction, so this portion wave which passes through one layer to other layer depends upon the type of the material. For example, the velocity of the rock type 2 is greater than the velocity of the rock, you can get this kind of refraction. Okay. So, when the type of the rock 2 is less than the type 1, then you can get this kind of refraction. So, these are all will give you what type of seismic wave you have recorded and what material it passed. So, that is the understanding will help you this kind of understanding of wave propagation. We also seen dispersion. The dispersion is basically separation of the wave. So, some materials which separate the waves are it makes vibrate several times, it depends upon the property. So, that kind of things are explained in the dispersion. So, the attenuation is some material will modify the wave amplitude, okay, wave character will be modified. So, the attenuation is basically reduce the wave amplitude is called as attenuation, increase the wave signal strength or wave amplitude is called as amplification. So, more or less the four major phenomena which occurs during the wave propagation: refraction, reflection, dispersion and attenuation or amplification. So, these are the four major phenomena it occurs. So, this occurs with respect to the waves it travels. So, the seismic waves, even though we call it as a whatever vibration produced wave as called as all of them as a seismic wave, these waves are categorized two type, depends upon the how it travels and how the medium respond to that travel. Okay, so, there are two type of wave, one is the body wave, another one is the surface wave. So, body wave basically travels body of the earth. So, that means the deep earthquake can cause a body wave traveling. Okay. So, the surface wave travels on the surface of the earth. So, even though this is a very simple explanation, body and surface with respect to the which part of the medium it travels, but precisely to express, scientists taken a reference as a particle motion in the particular body. Okay. For example, so this is the wave which it travels, then you will encounter a medium or a rock. So, this is any medium or rocks are a assemblage of several particles. How this individual particle respond to a wave, then based on this particle movement they try to define a wave type. So, the body wave has a two major category, one of them is compressional wave, another one is the shear wave. The surface wave has two category, love wave and Rayleigh wave. So, the compressional shear wave basically indicate a particle behavior, that means particle is compressed, particle is sheared. The surface wave basically love and Rayleigh waves named based on the scientist who invented that wave. Love and Rayleigh are the person who invented that wave. So, let us see how the compressional wave travels. So, you can see here this medium very clearly, the waves are created by the rupturing, then the waves are traveling. You take this particle as a reference, you can see that during this wave this basically compress and elongate. So, the particle compress and elongate, direction of the propagation of the wave, that wave is called as a compressional wave. Okay. So, our primary wave is called as a P wave. Okay. So, this is the typical animation shows that the wave propagation occurring on the P and so the other portion. So, where the earthquakes are occurring, waves are traveling. So, the particles are basically moves perpendicular direction of the wave. You can clearly watch this particle, you can see here. So, this move basically perpendicular to the direction of the wave. So, this kind of wave, particle motions are perpendicular to the direction of the wave propagation. This is called as a S wave. Okay. So, it basically happens, create a shear between the medium and particle. The particle to particle, that is called this is a shear wave or S wave. So, then the portion of the wave when travels, the particle basically rotates. Okay. So, the particles are rotating with respect to the direction of the wave propagation. That wave is called as a Rayleigh wave. The Rayleigh is the person who invented this wave. So, since the rotation is involved where the free body also come into picture, the rotation is major at the surface of the system and low at the bottom of the system. You can see very clearly how the rotation take place, you can see. So, basically the larger rotation happens here and then less rotation happens here. So, this is a unique character where the rotation happens, but rotation also with respect to the depth it happens. So, this is a surface wave, but it is a Rayleigh type of surface wave, travels on the surface of the earth. So, the another one is the love wave. So, love wave is basically movement of the snake, you can quote. So, where the particles are basically perpendicularly moving with respect to the wave propagation, but not vertical, it is horizontal. You can see that it is horizontally perpendicularly moving. Okay, you can see that movement again major at a surface and then reduces with the depth. You can see this is how the particle, you can see the each grid, how the grid movement occurs on top and bottom. So, this is the love wave. So, basically the love wave is created, okay, so invented by the scientist Love, which created at the surface of the earth, okay, during the earthquake or any vibration travel. So, these four major category of the wave characters are very important in the engineering seismology. So, let us see what are these wave as a characters. So, the P wave, compressional wave, primary wave or longitudinal wave. So, actually alternating the compression the same direction as the wave propagating. How the particles are basically compress and dilate, and which goes like the Vp is equal to so much, it travels with the speed of 5 to 7 km per second. So, in the solid medium, and 1.5 km per second in the water and 0.3 km per second in the air. This is the typical velocity you can expect. So, this velocity may vary 5 to 7, but it may be 5.5, 6.5, it depends upon the location. So, generally smaller and higher frequency than the S wave or surface wave. P wave is liquid or gas or pressure waves, including the sound waves. So, whatever I am speaking, okay, the sound which creates traveled in the air, no, those kind of waves are called as a P wave. Okay. The shear wave or secondary wave. So, the alternating transverse motion or particle motion in a vertical or horizontal plane. So, this has a velocity range of 3 to 4 km in the typical earth crust, and the S wave do not travel through fluid. S wave travels slower than the P wave in a solid, therefore, arrives after the P wave. Here you can see that S and P wave. So, the P wave velocities are higher, that means it comes very fast, S wave comes next. Second, the P wave travel on water and the S wave does not travel on water, that is the second. Third, so you can also see that the material property which we discussed during the wave propagation. So, here the P wave is controlled by the constraint modulus and density. So, the S wave controlled by the shear modulus, density. Okay. So, if you want to get a Vp and Vs relation, basically there is a relation derived with respect to the density, Poisson ratio and modulus. So, you can convert one wave to other wave by knowing this kind of properties. So, the other wave basically is the love wave, a surface wave or long waves. So, the travels horizontal motion perpendicular to the direction of the propagation and generally parallel to the earth's surface. It has a velocity range of 2 to 4.4 km in the earth depending upon the frequency, faster than the Rayleigh wave. So, the love wave comes first. Okay, so it is faster than the Rayleigh wave. So, but it velocity also depends upon the frequency content of the wave, that things you note. Previous two actually not that much depend upon the frequency content. Decrease in amplitude with the depth. So, dispersive velocities depend upon the frequency, low frequency propagate higher velocity. So, lower frequency penetrating to the greater depth. So, the Rayleigh wave, surface wave, long waves are ground roll. Motion is both in direction of the propagation and perpendicular where it rotates. So, the velocity range is 2 to 4.2 km in the earth waves. Dispersive amplitude decrease with the depth, appearance like a water waves. Depth penetrate depends upon the frequency, lower frequency penetrate to a greater depth. So, if you go to the water body next time, you throw a stone. When you throw a stone, so you will get a wave, okay, in the circular wave, the waves are traveling like this. No, that waves are basically Rayleigh wave. Okay. So, that kind of waves basically water waves are. So, love waves are basically snake movement, that is a typical example. So, all these animations, okay, the wave explanation, animation, simple experiment are available in the YouTube. So, you can actually browse it and get exposed to more the content, how it travels. So even though the theory assumes like this homogeneous heterogeneity medium and infinite depth and semi-infinite and all, but we don't want to basically too much explain on that, which is not required for the introduction class kind of things. Okay. So this is about the wave character. This wave property are very important to interpret a seismic data recorded at a particular place. So if you have the seismic record, you should know what type of wave you are recorded. So this wave property also defines the earth interior. So people have recorded these waves at different places and then try to understand how the particular place, what type of wave you received by the wave propagation theory, based on the wave propagation theory only. So we have seen some animation basically. So you can see this animation. So the earthquake originate at one place and then it moves at a different place. You can see what type of wave and when it arrives. So for example, this is the origin, earthquake is originated. So then it moves. You can see the what type S wave, P wave, when it travels, P wave, when the S wave, and how the your house or a typical house get disturbed or object in the surface disturbed. So you can also see the amplitude with respect to different position. So this is the wave. So when you are seeing that the S waves are not traveling the interior, that means some location you cannot get a record of S wave. Okay. So those locations, okay, where you are not able to receive a particular wave, that depends upon the your origin of the wave and the position of where you are looking at. For example, in this figure the earthquakes are occurring here. So you try to have the earthquake recording at several places of the world. If you see this very clearly, you can see basically this position, this position, this position, this position. So the waves are traveling all around direction, but one at particular location you may not receive a particular wave, depends upon the wave character. Per year you may not receive a S wave as the interior of the outer core of the earth is basically your liquid. Okay, liquid means not like water, it is relatively comparatively density of this material mantle and outer core are different, which is similar kind of solid, very thick liquid kind of thing where it does not travel. So this decides a particular zone or area do not have particular wave type. So then that defines a shadow zone. So if this is the place you see the earthquake is origin, this is the place earthquake is origin. So then it travels all along the direction. Scientists observed that the 103 degree from this middle 103 degree and 140 degree. Okay, so this portion you will not receive a P wave because of the refraction. Okay, so refraction and reflection you will not receive the P wave on this as well as this. This zone is called as a P wave shadow zone. This particular zone is called as a P wave shadow zone. Similarly, you will not receive the S wave from 103 to 103, this entire location. That location is called as a S wave shadow zone. Okay. So when it hits, the waves are transferred into different type of the waves. So like you can see here, this is the typical earthquake recorded continuously at different places, or the simulated this record at different places. You can see that. So some places the P wave record, some place the combination of P wave and S wave record, some place only S wave record, some place only P wave record. So this is like the waves get transformed, P wave get P wave, P and S wave get S wave, S wave and SP wave, something like that. The waves are get transferred into different portion. So depends upon the where you expect your record, where the wave origin, you can get a particular type of wave, or you don't get a particular type of wave. So this concept has been used to understand the seismic record. So where it occurs, this is a typical earthquake. You can see that here the P wave components are less. So here the P wave components are considerable, here much higher. So there are different P wave and S wave component and where it lies, so the S wave and Rayleigh wave. So this kind of record will give you the details of that. So if you record this at several places, you can try to understand the medium properties using this arrival time. Okay. So, that is like used to understand the earth interior and density. So, you look at this plot, this is actually the cross section of the earth. So, which is the surface, how the P wave, S wave and density varies with respect to depth. So, this is the atmosphere, the crust, upper mantle, lower mantle, outer core and inner core. You can see that outer core there is no S wave, okay, because it is a liquid, there is no S waves are taking place in the outer core. And this basically throughout, if you cut a particular place, you will not see the your S wave become a 0 at outer core, then again it goes. So, this kind of measurement and understanding help to develop a primary earth reference model. That means the entire earth system, okay, the globe actually taken this kind of different level velocity and try to understand how this velocities varies at a particular depth. So, this is actually a typical difference of velocity at 2088 kilometer deep from the surface. Okay, the surface you take it as a surface of the earth, then from so many kilometer below you can see. So, you can see the material difference. So, in particular places you can see 2-3 the difference are large and some places the difference are negligible. For example, here there is a uniform Sri Lanka entire this same, India also same, but in between Sri Lanka and this one there is a joint. Okay, here you can see the Australia, you have the 3 type of this one. Okay, the difference is large even at a 200 kilometer deep. So, this will give the your interior of the earth and material present in the particular location. So, this plays very important role in the deep geophysical exploration. So, people try to find out material present below the ground using this kind of survey. Okay. For example, oil, after 2 kilometer, 3 kilometer they found oil, they find gold, they find the coal, okay, after 1 kilometer or 100 meter, 200 meter. So, this kind of survey, geophysical survey will help to basically get the minerals and then the subsurface content in that, they do extraction of that and then basically use it for the human application. We have seen the gold was extracted from KGF. So, they found gold, okay, so by kind of exploration and then try to extract that. So, not only gold, there are several minerals like a diamond, all those things. So, this deep geophysical survey is the another branch of study. People will involve on oil exploration, mineral exploration using the seismic waves. Whatever you have studied so far, seismic, these are all the waves they use to interpret what type of material it is, how the density varies, how the nearby material and that material. Then they try to drill and take a sample and do an analysis and find out the materials is worth the extraction. So, iron ore, copper ore, okay, the aluminum ore, all those mining actually done after doing this kind of deep geophysical survey, okay, using wave propagations or seismic waves what we study. So, this is plays a very important role in the mining activity, mineral exploration, all those things. So, in the seismology part also, if you want to understand the earthquake location where the earthquakes are occurring, okay, if you want to understand the how far from your location to earthquake, these wave propagation theories are very useful. Okay. So, we can also see some animations where there are waves, how it is generated. So, you can see the seismic record. So, this is a typical seismic record. So, where you can see the type of waves you receive at a particular place. You can see here. So, this is a seismic. So, you can see the movement of the object, even though the building was shown very big movement for the given event, but it shows how the seismogram record this event. Okay. So, you can see basically, see, I just start once again to closely watch. So, we should thank this, and you say this is the wave it created. So, you can see the wave, so where the S wave P wave traveled, S wave traveled and then the SS wave. So, if you have the seismic station here, you can get all of them. So, this seismic station, as we are expected that it has a 3 component. Okay. So, 3 component wave. So, each component you get a particular wave recorded. So, generally the vertical component P wave record very higher amplitude. Okay. So, the two horizontal component it does not record so much, okay, that one. Then the other waves, so like the horizontal component will recorded well at the place where your horizontal direction, the vertical component may not be recorded. You can see the how typically the object moves on your amplitude. So, east west, north south, okay, how it behaves, okay, your object or how it behaves. So, even though this shown very high level of vibration, this is basically to understand how wave propagation it basically see here P wave, S wave, see how it moves. So, such kind of movement is taking place in the any object due to the earthquake. So, that is what you are trying to capture. You can see this earthquake occurring now. You can see the P wave traveling, S wave, surface wave. These waves are moving towards. You can see when it reaches to the object. So, it lift the horizontal, see, then you get a recorded here. Okay. So, then the other component, two horizontal, this is a vertical component, two horizontal component, you get only the minor disturbance. Then the S waves are coming now, it is going to hit a object. You can see the S wave record on horizontal component dominantly, you can see, but the vertical component record it is only small amplitude. So, similarly surface wave going to hit the object, you can see the waves are coming very close to the object, going to hit you. So, when you hit here object, you can see how the object rolls, basically see it rotates and also like a water waves it moves. You can see the component. So, basically the S wave and a surface wave predominantly recorded in the horizontal component, which is north south and east west, and then the P wave predominantly recorded in the vertical component of the seismometer. So, this will help you to interpret what type of wave you recorded at a particular place. So, this also useful to interpret a data. So, now last 4 lecture we have been recapping the what we discussed in the different portion of the syllabus. So, that this knowledge whatever we discuss will be useful for getting the prediction of the earthquake hazard. Okay. So, that is why we are discussing these topics. So, we will continue this few more topics what we the balance, and followed by we will work on how you can use this knowledge for application side. So, that is the reason. Okay. So, thank you very much for watching this video. We look forward. So, next class. So, thank you.